This lesson is a part of a series of lessons on the electromagnetic spectrum. Today's title is infrared. So we'll start with our key terms. We have infrared, optical fibers or fiber optics, spectrum and prism. So I'd like you to start with your recall tasks. State the speed of light and state the electromagnetic spectrum in correct order from highest frequency to lowest frequency. And consider, is visible light the only part of the electromagnetic spectrum that we can detect? Pause the video at any point you need to write down notes. So a clue for your recall tasks: the speed of light is 3 something, and the electromagnetic spectrum in order from highest to lowest frequency is. Again, pause the video if you need to write anything down. So let's look at our answers. The speed of light is 3 times 10 to the 8 meters per second. That is 300 million meters per second. And the electromagnetic spectrum from highest to lowest frequency is gamma rays, X-rays, ultraviolet, visible light, infrared, microwaves, and radio waves. So gamma rays are the highest frequency and radio waves are the lowest. So here's a glossary of our terms. If you don't know any of these, or you didn't know before, make sure you write them down. We have infrared, which is the part of the electromagnetic spectrum associated with thermal radiation. Optical fibers are thin glass fibers that guide visible light and infrared, and they're used for communication. Spectrum is essentially the band of colors we see in the rainbow, but can also be used to refer to any range of frequencies in the electromagnetic spectrum. And a prism is a glass block with 2 triangular faces used to separate white light into the spectrum. So the question is, what is beyond the visible light spectrum? Is anything beyond the visible light spectrum? Well, this was discovered purely by accident. We know that infrared now is at the far red end of the spectrum. That means it has a longer wavelength than red light. It also means it has a lower frequency and a lower energy than red light. Now, prisms can be used to separate light into the spectrum. But what you might not have realized is the prism is also separating out the parts of the spectrum that we can't see. So infrared was discovered by a person named William Herschel. William Herschel was investigating whether different colors of light carried different amounts of thermal radiation. So in other words, would different colors heat things up at a different rate? So Herschel placed a thermometer at each of the different locations on the spectrum. So at red, orange, yellow, green, blue, indigo, violet. Now Herschel also decided to place a thermometer off the red end in an area that wasn't being lit up. Herschel did this as a control in case the whole room had changed temperature, and that would give a false understanding or a false reading. So this was a control thermometer. What Herschel then discovered was purely by accident. Herschel discovered that the thermometer that was just off the red end of the spectrum increased in temperature the most. This demonstrated to Herschel that there must be an invisible form of light that was increasing the temperature more than red was. Herschel then decided to name this infrared because it was next to the red end of the spectrum. So some of the applications of infrared: since we know it's used for heating, we can use it to cook food. We can use it for something called thermal imaging. So the hotter an object is, the more infrared light it gives off. So here you can see some extremely hot pipes surrounded by a cold environment. We can also use it for night vision. Now this is a different frequency of infrared. which is further away from the visible spectrum. You can use a torch that emits only infrared, so humans can't see the light being produced by this torch. But you can use special cameras to detect that light. In fact, most people's mobile phone cameras will detect infrared. So you can test this out by shining an infrared torch or using a remote control that would be used for your television and using your camera to look at the end of the remote control when you press the buttons. Now, fiber optics are also using infrared, and the reason they use infrared is because infrared is actually absorbed less by the glass than visible light. So you can send visible light down fiber optics, but as it travels, gradually that intensity of light decreases because light is absorbed. Infrared is absorbed less by the glass, and so it's able to pass longer distances, maintaining a high intensity. So what happens is you shine an infrared light into one end of the glass. That light is reflected on the insides of that glass fiber until it reaches the other end. And finally, as I mentioned earlier, remote controls. So a remote control from your television is used for short-range signals. Now the reason this is for short-range signals is because infrared light will be gradually absorbed by the atmosphere. And so that light can't pass as far as a few kilometers. Otherwise, it will be absorbed, or at least the intensity will be much, much lower at those distances. Now, you might ask, why doesn't a remote control burn you every time you press the button, or if you aim it at someone and press the button? That is because the intensity of light produced by the remote control is very, very low, and the frequency used by the remote control is also not the same frequency that's used to heat objects in a cooking device. So just like light has different frequencies, we have different colors, red, orange, yellow, green, blue, indigo, and violet. Just like violet is very different from red, so too the infrared light used by a remote control is different from the infrared light used in cooking. It's at a different end of the infrared spectrum. So what are the dangers? Well, first of all, skin burns. So at high intensity, infrared heats objects and can cause burns. Now, this is not to be confused with sunburn. Sunburn is a completely different issue. A skin burn caused by infrared is like when you stand too close to a fire and you can feel the heat. You don't get a tan, but you can get burned. And in fact, this reveals the answer to the question I asked you to consider at the start. We can also detect infrared, but not with our eyes, with our skin. Just like how you can place your hand next to a radiator and you can feel the warmth without touching it, just like even blindfolded, you can detect which direction the sun is in because of the infrared light that makes it to your skin. And another danger, we don't have any. Infrared and surfaces. So consider for a moment which of these surfaces will absorb the most infrared. So we have black versus shiny, copper versus white, and white versus black. Consider your answer now. So in this particular case, a black surface will absorb infrared more quickly than a shiny surface, because a shiny surface will reflect it. A copper surface will reflect some of that light, because copper is shiny. And so the white surface will actually absorb more. And finally, a black surface will absorb more than a white surface. However, when we look at emission, consider the same question. If you had this cube filled with hot water, which would emit infrared light the most? Now, most people think it's probably the opposite way around. In fact, you would be wrong. It turns out that the black surface is also the best emitter. A shiny surface is not a good emitter of infrared light. So in the first option, the black surface will emit more than the shiny, the white surface will emit more than the copper, and the black surface will emit more than the white. We can see this when we do a thermal image of this cube that we call a Leslie cube. Here you can see two images. We've got in the first top left one is a thermal image, and below it is the black and white image of what is actually happening. You can see in the black and white image you've got a black surface that's matte black, and you've also got a shiny surface, and you can see the reflection of the hand. You notice in the picture above you can actually see the thermal reflection of the hand as well in that shiny surface. But you can also see the black surface is far, far better at emitting infrared light. Meanwhile, a white surface is also better than a light silvered surface. So the key points from this lesson.